Hello, and welcome to Astronomy 100. In this segment, we're going to begin our discussion of the moon. And in this particular video, what we're going to do is describe all of the features of the moon as a natural body of our solar system. The moon is the Earth's only natural companion, and it is technically referred to as a natural satellite. Its name is actually the moon. There are other natural satellites in our solar system, and they all have names as well. Now, let's begin our discussion about the surface features of the moon here. When looking at the moon through a telescope, you can see a lot of things that you cannot see with the naked eye. And it was actually Galileo in 1609 that was the first to be able to use a telescope and see the features of the moon. What Galileo noticed is that the moon seemed to be covered with lots of holes all over its surface. And you can see in these drawings here how he's portrayed all of the holes all over the surface of the moon. If we take a close-up look here, we can see that these holes are actually rather large in some instances and small in other instances. There are countless numbers of them. They overlap each other, and sometimes there are holes inside of holes. Galileo coined the word crater to describe these holes. Crater is the Latin word that means bowl. From again, without the view through a telescope, you can't see these craters too well, but up close you can see that they're everywhere. Originally, Galileo and other scientists of the day believed that these holes were caused by volcanoes. Volcanoes have the ability to break through the surface of the Earth and create a hole on the surface, such as the one that you see here. This is a volcano from one of the one of the islands of the Hawaiian island chain. But there are other places on the surface of the Earth where there are holes that are not associated with volcanoes. These are holes that are created by impacts. In other words, objects hitting the surface of the Earth from outer space. These objects hit the Earth and create holes in the ground. And the most famous one in the United States is the one in northern Arizona outside of the city called Winslow, Arizona. And recently, we took a video camera to this location and had a really nice tour of this crater and learned all sorts of things about it. Let's have a look at this video. So here we are at Meteor Crater in Arizona. We're about 40 miles east of Flagstaff, and we have Derek Orgill with us here. He'll be our tour guide for today. Thank you for joining us here today.
You're welcome.
So can you tell us a little bit about the history of the crater?
The history here started 50,000 years ago when a meteor came from the asteroid belt from the east. Now, as far as the human history goes, it was first discovered in 1871. An Army scout named Franklin wrote down a few notes in his logbook about an odd-looking hole in the ground. Not too much was thought about it at the time. And in fact, it really wasn't studied until 1891. At that time, the chief geologist of the U.S. Geological Survey came out to study the crater, trying to prove the theory that this might be an impact site. After several tests were done inside the crater and out, he thought this was just the result of volcanic activity, a steam blowout. And for the most part, everybody accepted that theory. A mining engineer from Philadelphia arrived here in 1902. He heard about some of the meteorite being found all around the crater, so he came out to look at it for himself. His name was Daniel Moreau Barringer. Now, Barringer was convinced this was an impact crater. He was so sure that inside the crater was a giant meteorite, he got the federal mining rights to the crater in 1902, authorized by an old hunting buddy of his, Theodore Roosevelt. Now, Barringer got a few investors on board, came back to the crater in 1903 with two primary goals. Number one, to prove this was an impact crater. Goal number two was to make a little bit of money.
Always money.
All right, helps. Now, Barringer started mining inside the crater near the floor, near the center of the floor. Now, after coming up empty on the floor of the crater, Barringer tried drilling several more locations throughout the crater, inside and even along the rim. 26 years of mining for that giant meteorite. He was not successful. Mining operation at the crater stopped in 1929. Barringer had enough information to declare this was an impact crater. However, the scientific community wasn't accepting it. wasn't finally accepted as an impact crater until many years later. Now, tourism started here in 1942. The Bartee Bar Ranch had acquired all the surrounding land around the crater and entered into a long-term lease for a portion of the rim with the Barringer family, and tourism has been the staple here ever since.
So whatever happened to Mr. Barringer?
Daniel Moreau Barringer died in 1929. After coming up empty, he returned home to Philadelphia. The stock market crash.
So just that was the end of it, huh?
That was the end of the mining operation in 1929. Now, the family really wasn't sure what to do with the crater.
Yeah.
And at one point even offered it to the National Park Service.
Oh, interesting.
Their response at the time was, "We already have our hands full with one big hole in the ground in that state. We'll keep the Grand Canyon. Thanks, but no thanks." So the Barringer family ended up keeping the crater, and they still own the crater today.
Now, so there are fragments that have been found, obviously. There's the fragment in the visitor center. So there was clearly something that he did end up walking away with, just not the mother lode he was expecting it to be.
Right. What happened was they were finding meteorite material all around the crater. Barringer thought there should be 10 million tons of iron nickel sitting inside the crater somewhere,
Okay.
not realizing it had exploded on impact. Now, that Holsinger meteorite was found in 1911, 2.5 miles west of here, laying out along the rim of Canyon Diablo.
Okay.
And it was found by a gentleman named Samuel Holsinger. Holsinger was basically the foreman of the mining operation.
So there's been a lot of history about activity at the bottom of the crater since Mr. Barringer. I know the Apollo astronauts did some training. Can you tell us a little bit about that?
The Apollo astronauts came here to train before their initial missions to the moon, the Apollo astronauts. They used the crater as a laboratory to actually study the geology of an impact crater, to kind of figure out what they were getting themselves into before going to the moon.
How many days did they stay here? Did they camp at the bottom or anything?
The training for the Apollo astronauts started in the 60s, and it went all the way up through 1971 to 1972.
Okay.
So they did years of training here, learning about really the geology of an impact crater, and they had a chance to test out some of the equipment here.
Interesting. So how many acres total does the family own surrounding the crater itself?
The Barringer family really owned the 2 square miles the crater sits on. Now, those were acquired through those federal mining rights.
Okay. Well, thank you very much.
You're welcome.
So we're back. So Derek, I know that there are nearly 200 impact craters around the world that we've identified, and of course Meteor Crater is one of the most famous. Can you tell us what some of the evidence is that this is truly an impact crater as opposed to something volcanic in origin?
All right, that's a great question. In the early 1900s, there was only one thing scientists would really agree on right here. An explosion had occurred. Inside the crater, you'll notice the cliff walls are all sitting up at an angle. We have an uplifted strata. Another thing you'll notice is there's an inverted stratigraphy. These red rocks we're standing on should be the top layer of the Earth's crust right here in this part of Arizona. It's Moenkopi sandstone. Now, it's underneath everything that was once below it. That's your inverted stratigraphy. Anytime you have a crater with this uplift, ejected material, you've had an explosion. That's the one thing they would agree on. Wasn't finally accepted as a meteorite impact crater until much later. The 1960s, Dr. Eugene Shoemaker arrived at the crater. Dr. Shoemaker did some groundbreaking work right here to finally get the scientific community to accept this as an impact site. Inside the crater, Dr. Shoemaker identified 2 minerals that do not occur naturally on this planet. Those minerals are a denser form of quartz, coesite and stishovite. Now, finding those high-pressure minerals inside the crater meant this couldn't have been a steam blowout. Had to be the result of a meteorite impact. And because of that very work, nearly 200 impact craters have been discovered around the world.
So walk us through, let's say, if you could witness the event 50,000 years ago, can you walk us through what would have occurred and maybe some of the aftermath of the actual impact?
50,000 years ago, you would have seen a pinpoint of light to the east. It would have grew in size to a fireball. Upon impact, there would have been a huge explosion. That explosion threw out 175 million tons of earth rock. You wouldn't have wanted to be anywhere close to the area because the shock wave would have killed any living mammal really within 7 miles,
Wow.
about 10 kilometers. Hurricane force winds over 20 miles in every direction.
Amazing. Now, the actual impactor itself, tell us a little bit about the meteor itself that hit
The
ground.
meteor itself, the current estimate is that it was 150 feet in diameter and that it weighed nearly 300,000 tons.
And the material that it's made out of, mostly iron, or?
Mostly iron. It's 92% iron, 7% nickel, 1% with about 80 different trace elements and minerals.
And if you were to have a piece of the meteorite itself, is there evidence to prove that it came from space? Let's say you were to pick something up off the ground. How do we know that's a space rock as opposed to something on the landscape?
A couple of different ways. One, right off the bat, in this area there isn't a lot of iron sitting around. So if it's magnetic right off the bat, you have an indication. It's really the trace minerals. The trace minerals include iridium, platinum, cobalt, chromium. When all of that is mixed together with iron and nickel, it makes it very unique.
So something that's not really you would find normally on the surface of the Earth.
Right, iridium is very rare to find in the Earth's crust.
Okay.
Very common in meteorite material.
And the portion that you have in the visitor center there, it looks like it's pitted on the outside. Is that evidence of it coming from space, or any, I mean, is that a giveaway that it's a space rock, or so?
It's evidence that it got superheated. That's why it has that unique shape, kind of looks like flowing marks. Also the little holes, those are ablations.
Okay.
It became so hot, lighter materials melted out, forming those little pockets.
Okay. And smaller pieces still littered around the landscape, or?
Still being found today. There's no active searching done today at this time.
Sure.
But it would be very hard to miss a meteorite laying out there. I mean, it's all around. I don't think it'll ever be gathered up.
Yeah, that's very true. Driving in, we noticed that there seemed to be mounds of dirt scattered around. Is that related to the impact? Any ejecta material that's scattered, or?
The ejected material you can really identify is all the tan-colored boulders, rocks that really offset against the red in the surrounding plain. The red boulders, for the most part, farther to our north, those are natural erosion.
Okay. And I noticed looking at the crater, you can see places where it's been eroded over time. And so can you tell us a little bit about the dimensions of the crater itself?
All right, the crater today is 4,000 feet in diameter, nearly a mile across, 2.5 miles in circumference, and 550 feet deep. Now, when this first happened 50,000 years ago, the crater would have been deeper, closer to 700 feet deep. But mainly due to wind erosion, we've lost 150 feet of total depth here at the crater.
So what we're seeing is 50,000 years worth of natural erosion, the wind, the rain, and I imagine at some point in the future, this will just be a tiny scar on the landscape if we go far enough in the future.
Far enough in the future, yes. Geologically speaking, the crater is very young, and because of the lack of water, the annual rainfall in the area, that's why we're the most perfectly preserved impact crater on the planet today.
Do you get a lot of scientists who come to the region to study it as a good example of an impact crater?
Yes, this is one of the most famous ones in the world, not only because of how young it is and how preserved it is, but it's easy to access. We're just right off of Interstate 40, so every year scientists come from all over to study here at the crater.
Well, thank you very much for your time today. I appreciate the tour.
You're welcome.
So as you can see, Meteor Crater is an excellent example of a typical impact crater here on Earth. Has all the hallmarks of something coming from space to create this hole in the ground. And I hope you've enjoyed our tour of Meteor Crater. So you can see the Meteor Crater location in northern Arizona has many things to learn about impact craters and how the Earth, of course, is the recipient of these objects from space creating these craters. Now, in the future segments, we're going to talk about how there are other places on Earth that have craters as well, and we're going to discuss why is it that the Earth has very few craters, whereas the Moon has just countless numbers of craters. And then we're also going to look at how other solar system bodies are cratered bodies as well. And then finally, we're going to describe how the formation of the Moon itself is indeed related to this cratering process. I hope you'll join me.